So if you guys have your lab in front of you, it'd be very helpful. So long story short, there are two parts to this lab, okay? Part one, where you guys have heard this all week long. You're gonna look at 7 chemical reactions, most of which we talked about when we did the little sheet where you're looking at the electron dot, and we were talking about oxidation reduction and the types of reactions, and I pointed those out as I did that lecture. We're gonna do this one, this one, this one. So you guys have talked about most of these. But I really want you guys to go into the 4 indications of chemical reactions, right? So I want you to see a precipitate, which you have already seen, but they were boring. I want you to see the evolution of heat and light. So you'll get both of those today, and I'll tell you where to be careful about that. You're gonna see a dramatic unexpected color change, okay? And you're gonna see, the evolution of a gas. And we're actually gonna light that gas in here, okay? So those are the 4 fundamental things that you will be looking for when chemistry happens, okay? So if you guys will look at your front page, you'll see that there's directions for all 7 reactions, and included in those directions are the reagents or the reactants and the type of reaction it is. So basically we've done half the reaction for you, okay? And so you guys are going to write the products and the state, and I'll remind you that states can be gas, liquid, aqueous, or solid, okay? And then I want you to balance the equation, all right? So that's the second, that's the big thing that you're doing in this part. The other thing I want you guys to work on is I want you to work on your words. So this is the qualitative aspect of chemistry. Remember, we have quantitative, which deals with numbers, and we have qualitative, which deals with just descriptions, okay? So that's really what I want you guys to work on is your descriptions. So on the data table, if you turn there really quick, you'll see there's a small space. So you don't have to write a lot, but you're gonna write a small space of observations. What do you actually witness, okay? And I would encourage you to sort of look at the reactants before they get reacted and talk about how it's changed. Talk about the color change. Talk about what you see in terms of temperature and gases and all that stuff. Okay, does that make sense to everybody? Okay, so I'm gonna walk around and just kind of identify all the 7 reactions really quick and give you cautionary measures and that sort of thing, all right? So first reaction, I've actually changed it in the lab, so I don't know if you got the newest version or not. You're gonna utilize these test tubes, so you don't have to clean, you do have to clean them when you're done, and they just go back in here, but you don't have to put them back in your drawer. So you're gonna add, for the sodium iodide, you're gonna add about 1 ml, okay? And I want you guys to remember, these are graduated pipettes, and this one I think is a 2 ml capacity. So it's always a very important thing to do is when you walk up to the pipette, you wanna make sure you know what the volume is. What are the graduations, so that you don't add twice as much reagent as you need to. So about 1 ml, I want you to practice, right? Squeeze the bulb, stick it in the liquid, let go. It comes all the way up the bulb, and then you squeeze it down to the volume that you want. So practice that, okay? So that's how that goes, and I'm gonna ask again about contamination, so be really mindful. Scott makes it so easy. When you're done, put it in the little container, and you don't have to get contamination. And that's because you'll get this precipitate in the containers if you get them contaminated. This is where you're gonna put the 2 to 5 drops of, this is lead nitrate. And so basically, make sure you screw the tops back on when you're done too. That's always good. All right, so that's the first reaction. Waste goes in the waste jar, and then you can rinse the test tube and put it back in the test tube rack, okay? Number 1, okay. Number 2, you guys are gonna practice using the Bunsen burner, right? And you guys know how to light that with your striker. So you get to use the striker again. You're going to utilize these test tubes, so not out of your drawer, and a test tube holder. So basically you're going to use the test tube holder and hold on to the test tube. You're going to put a very small amount, using this spatula, of copper carbonate in the test tube, all right? And then you're going to, again, use those good policies of turn the test tube away from you and hope nobody's standing over there. It goes in the flame for a little brief time till you see a color change. You're gonna note the color change, and then the test tube can just go in the waste jar, okay? Got that? Good, okay, that's reaction number 2. Reaction number 3, repeat, Bunsen burner, striker, right? Okay, You're going to use sucrose this time. Remember, that's a disaccharide we talked about in our biomolecule part. You're going to use this this little spatula this time and a little tiny test tube. Scoop up a bit, put it in here. It won't be very much. That's okay. And again, you're going to use a test tube holder, right, to hold the test tube, and then it's going to go in the flame. If you burn this too much, it'll smell like burnt marshmallows in here. Okay, so you're just looking for a color change. And please look for what else you see in here. You'll see some liquid in here, so just mind that. So take a good observation. Okay, those test tubes can just go in the waste beaker. Everybody got that? Okay, so that's experiment 3. I'll just say you do not have to do these in any order, okay? And I am gonna follow you around and film you, okay? All right, so over here, this is experiment number 4, and we're gonna actually take a piece of magnesium ribbon, which we will use again later on in a different capacity. These are tongs, and you guys haven't used these yet, so I'm trying to point out the stuff you haven't used. You're gonna hold that magnesium strip with the tongs. You're gonna light the Bunsen burner as you know how, okay? And this time I encourage you guys to note in the flame there'll be a inner blue flame and then an outer lighter flame. At the top of the inner blue flame, that's the hottest part of the fire. If you hold that in there, that'll go fast. We've talked about this in class a little bit. So this one, if you're really sensitive to light, you'll want to use your averted vision. Okay, meaning look at it at the side. It's going to be very bright. But I encourage you guys when you're done to really continue, really scrutinize. Well, this is a piece of metal. It's very classic. It's silver. It's flexible. And we call that malleable. And when you're done, the product is really, really, really different. And you should check it out. It's very different. Because this gives you that, yes, we have made a substance with different chemical and physical properties. So very, very different. So take some time to check that out. Okay? All right, moving on. Experiment number 5 and 6. Okay, this is a twofer. You're going to get 2 reactions out of 1. And I, again, encourage you guys, you're going to look at, this is magnesium also, and if your lab says zinc on it, maybe on the table, make sure you correct it, okay? It may have zinc on there. I fixed it, but I think you might, if you have an older copy, it's not fixed. So I encourage you guys to check this out, right? You're using the same metal. This is magnesium in a strip, and this is magnesium, we call it granular, right? But this is the same metal, so making sure you're observing those properties, so that's something to write down in your table. Okay, so here you're going to use another different type of spatula, okay? And in this test tube right here, right, you're going to put a little bit, and it shows you how much right there. So you're not very much. This is a very exothermic reaction, meaning it's going to get hot. And I have burned my hand on this before because I forgot to put my test tube in a test tube holder. So don't forget to do that. So you're going to put it in a test tube holder, and you're going to add a milliliter, I think, of hydrochloric acid. And again, I'm going to encourage you guys to practice using the graduated pipette. Squeeze it, put it in, pull it out. You're going to have liquid in the bulb, and you practice squeezing it down to the right volume. I can tell this one is a 1 ml capacity, and that one over there is 2. Okay. So this is the reaction you're going to get. It will happen very fast. So you're going to want your partner to be really fast, meaning they're going to have the flamethrower really, really ready. As soon as you drop the acid, which you're going to drop acid today, which is kind of cool. You drop the acid in, and then you're going to bring this to the mouth of the test tube really fast. If you do it right, you'll get a pop. Okay. You won't be able to hear it on the video. All right, but that's what's going to happen. The waste goes in here, so you're going to dump it in there, and the test tubes can go in here. Got it? Okay. All right. Last but not least, experiment 7. So essentially on this one, you've got new things here. So these are clamps that you haven't used before, so I encourage you to practice using them. That's part of this game, being in here. So you're going to put one test tube in the first clamp, whoa, better than that, and then the other test tube in the other clamp, okay? I think, can you guys read to me the volume you're supposed to add for number 7? It's on the back, the second page. It's not 5 mils, is it?
I thought it was.
5 mils.
Is it 5 mils?
Yeah.
Okay. Yeah, they must have not done 5 mils. Okay, so it doesn't have to be 5 mils, it could be more like 3. Because the other class, they had it all the way to the top and then they couldn't fit the thermometer in there. So you're gonna do 1 test tube of hydrochloric, 1 test tube of sodium hydroxide, okay? And I would encourage you guys to take the temperature of each of them before you start. So take the temp of one, take the temp of the other so that you can at least see what that is. And I bet they're gonna be about 22 because that's about room temperature. Okay, tell me again what the appropriate protocol is for taking temperatures. Did you not catch that? I said it once, I probably didn't say it to you guys. So it goes in the center of the liquid, not touching the glass, right? That's the best policy for taking temperatures. Make sure you're on Celsius, okay? And then turn that off when you're done so you don't waste battery. Got it? It's nice of you to take this and rinse it off a little bit when you're done, but that's good. Waste goes in here. Got it? Okay. You do not have to do these 7 reactions in any order. And you guys are so small, it won't matter, but we don't want you to get all bogged up. So you guys probably can do what you want because it's small enough class.
Jen,
right.
we are going to combine those, aren't we?
Yes, I'm sorry. Yes, you're pouring them together and then taking the temperature. So you're taking the initial temperature and then you pour them together and take the final temperature. That's what you're observing. So that's the reaction. Okay, thank you. Okay, so over here, we're going to talk about part 2. Okay, so what I want to tell you about part 2 is, again, there are 2 parts to part 2. So what I want you to see is this is our study of stoichiometry, which I feel like I at least gave you the information that you needed to do this part of the lab. I don't know that you've internalized it yet because there's probably a lot of practice you want to do to make sure you get it. And we're going to go over these calculations tomorrow. Okay, so this is the stoichiometric part of the lab, and you're going to do 2 parts. In both parts, the reaction, and I'll show it to you on the lab, you're going to do hydrochloric acid reacting with sodium bicarbonate, which is just baking soda. Okay, this is representative of the acid in your stomach, okay, because we're using Alka-Seltzer tablets ultimately, and that's what you do. When you have acid belly, you take Alka-Seltzer to settle it down, and it's neutralizing it, okay? And if you look at the reaction, you're going to make salt water and carbon dioxide, and that's probably why you burp a lot when you take Alka-Seltzer, if you have. Okay, so the first time we're going to do it, and then the second time we're going to do it again. It's the same reactant, it's still sodium bicarbonate, but it's in a tablet, okay? And in that tablet, there's only part of the tablet that is the sodium bicarbonate, and the rest of it is other stuff. It's citric acid to make it taste good, it's aspirin to make you feel better, it's other stuff. So when you do the first one, typically it's going to be very clean looking and very clear. And then the second one, it won't be. It'll be like all sort of shady and cloudy because it has the other stuff that doesn't react and is just left over in the Erlenmeyer flask, okay? We are going to calculate the percent difference, but we'll do that tomorrow. So let me go over the specifics of how you're going to do this. So I'm going to come back this way, all right? So you are going to use sodium bicarbonate. So the very first time you're going to do it, you're going to have your sodium bicarbonate and your weighing paper, and you guys have weighed enough things now where I feel like you know what you're up to, right? This goes on the balance, and this time I really do encourage you guys to fold it in half. Why are you laughing at me? You're smiling. Okay, so you're gonna fold it in force and just kind of make yourself a little weighing boat. It's easier that way, and the paper is really useful because it's gonna help you get it into the Erlenmeyer flask. So on the balance it goes, right? Tearing out the scale, right? Taking it off the balance to add the mass. And in this lab, it asks you to do, it's an ampersand, approximately 2 grams. I don't want you to waste time trying to get it exactly 2 grams. I want you to be somewhere near 2 grams, okay? But we want you to exactly write down what this says on the balance, okay? That goes in the first table, all right? So that's the first part of the lab. So basically, I'm looking at John's. So basically, if you'll come over here, John, you can flash on this example. So if you guys will flip to the second page, there is a reaction that I want you to look at. And so that reaction is the sodium bicarbonate with the hydrochloric acid. It's going to make water and salt ultimately. And that hydrogen carbonate, that's it, the reagent, I misspoke, is going to decompose into carbon dioxide and water. But really, ultimately, down here, you are going to get water and sodium chloride. And the darkened, the sort of bolded carbon dioxide, that is going to go off into the universe, okay? And the reason we're going to use this instrument that we're going to use, I don't like that one. Can you grab me an E-flask right behind you? This is called an Erlenmeyer flask, okay? And I want to talk a little bit about the shape of this and why this is what it is. So this is our E-flask, an Erlenmeyer flask. When we do this reaction in here, one of the things we want to do is we want the carbon dioxide to escape, right? But we don't want the water to escape, because what we're going to do is we're going to figure out how many moles of carbon dioxide went away, and that's going to tell us how many moles of the sodium bicarbonate is in our antacid tablet or in our first reaction. And so we don't want to lose water, and the shape of this container helps us keep the water in and let the gas escape. Does that make sense? Okay. So ultimately what you're going to do is we've got the mass of the sodium bicarbonate from the balance. That goes in the first box. You want to take an empty graduated cylinder, okay? So you're going to take an empty graduated cylinder. You're going to get the mass of that. That goes on the second box. That goes in the second box. This doesn't have a base to it. Then you're going to take the graduated cylinder and fill it up with 25 mils of hydrochloric acid, okay? What's really lovely and amazing about this experiment is it's all mass-based. And we have really good confidence in the balances as long as you read it right. And what I mean by that is we're not reading the meniscus, which is really hard, right? So this is all mass-based, so we should get really good results with this lab, okay? So you're gonna get the mass of the graduated cylinder with about 25 mils. We don't care really how much it is, we just want it to be near 25. It could be a little lower, that's okay. Get that mass, and then you're gonna mass the empty E-flask. That goes on the chart as well. And then basically what happens is, this is not going to stay upright. You're going to take your weighing paper that you weighed out your sodium bicarbonate, and you're going to carefully get all of it in here. Remember how we talked about percent yield today, and we talked about actual yield? That's where the mistakes can be happening. If you get any of this on the counter because it fell out, you're going to lose some of it. It's not going to be in there, right? So do the best you can to get all of that in there, all right? And then when you pour the 25 mils of hydrochloric in, it's going to go slow. So pour a little bit, swirl it, okay? Pour a little bit more, swirl it, and pour a little bit more, swirl it, all right? So now you've got this reaction, and you're going to see the carbon dioxide. It's the evolution of a gas. You're going to see it, okay? What you want to do is drive it all away, all right? So you're going to stir, and you're going to put it on the hot plate, okay? And the hot plate goes between 80 and 90 degrees, I think. The reason for that is we don't want to heat the water enough to boil it away. We just want to drive off the carbon dioxide. And it turns out that hotter liquids hold less gas. So if you have soda pop and you know that they're carbonated, they have carbon dioxide in them, and you'll maybe notice that when your soda is colder, it's more fizzy than when it is warm, right? So you should notice that. That's a thing. That's a chemistry thing. Okay? Good enough? Okay, so that's part one of part B. Are you with me?
Yes.
Okay, so you're going to do the same thing again. And by the way, this can go down the sink. That's okay. All right? Okay, so you're going to do the same thing again, but this time you're going to use an Alka-Seltzer tablet. Okay? So the Alka-Seltzer tablets, like I said, think that. They have a whole bunch of stuff in them, but they have a little bit of sodium hydroxide. So the exact same reaction, not hydroxide, sodium bicarbonate. They have the exact chemical reaction happening. But there's other stuff in the way, and those we could think of them as spectators. They're not really doing anything, okay? So again, if you look at the second table, there should be a place where you can put the mass, okay? So you're going to put the mass of the antacid tablet this time. So put it on weighing paper, and I encourage you to put it on weighing paper because you're going to use it in a second. So on the weighing paper it goes. Just tear out the weighing paper. You guys know how to do that. Get the mass of the tablet, all right? Same thing, we want the mass of the empty graduated cylinder, but don't bother cleaning it out. It's got acid in it, it's fine. Whatever mass it has is perfect. It's okay. Don't try to dry it out, it's all good. 25 mils of hydrochloric acid in, just like before. Weigh it again. Okay, again, you're not measuring exactly. Somewhere below 25 is perfect. Okay, empty Erlenmeyer, again, don't worry about washing it out. I would maybe rinse it to get the previous reaction out of it, dump it down the sink, put the wet thing on the counter, or on the balance, it does not matter. Okay, so don't waste time. So this time, you're going to use the magic chemistry hammer. okay? Because this won't fit in the flask, right? So we're gonna use the magic chemistry hammer and just gently tap it. You don't need to crush it into a million pieces. It just needs to be small enough to go in the flask, okay? So I had a student just wail on it and send it everywhere, all right? So just gently tapping, this is fine, getting it in there. And again, I would encourage, the whole thing, like tapping it in there so you get all of it. Same thing, add hydrochloric, slowly swirl, slowly swirl, slowly swirl. It will look cloudy. And then same thing, you're gonna stir it and heat it, stir it and heat it, stir it and heat it. When you think all the CO2 is gone, then you mass it. And I forgot to say this on the last one, but that final mass of Erlenmeyer and products, it's really important to get on the table, okay? In this lab, I would encourage you guys to use the same balance over and over and over again, because that might be a source of error, and we're trying really hard to get this really, really good data. Okay. Very last thing has to be the mass of the active ingredient. So you're gonna go to the label, okay, and on the label, I spewed off the number this afternoon in class, but you're looking for the active ingredient, that 1916 milligrams. That goes on the very bottom of the second, I guess it's the third table, okay? And then I will go through the calculations with you tomorrow, so you don't have to do them. You just need to grab the data, okay? Good? All right, thank you. Thank you.